Somewhere in a zoo, right now, a chimpanzee mother is nursing her infant. She is our closest living relative. She shares almost all of our genetic code. She grieves, she problem solves, she recognizes herself in a mirror, and her chest is almost completely flat. That is the strangest fact about the human body that almost nobody thinks to ask about. Among more than 5,000 species of mammal, creatures defined, named, classified by the fact that they produce milk, only one keeps a permanent, fatty, projecting breast on the female body throughout adult life, whether she is feeding an infant or not. Only one, ours. And here is where it becomes genuinely puzzling. That permanent fatty tissue has almost nothing to do with how much milk a woman can make. For most of the last century, the assumption ran the other way. Bigger must mean more. It felt like common sense, the same way it feels like common sense that a larger fuel tank holds more fuel. But when researchers began imaging the interior of the lactating breast, they found something that overturned the intuition entirely. The milk is made in glandular tissue, a branching network of tiny sacs and ducts that only fully develops during pregnancy. Everything else is fat, connective tissue, blood vessels, and skin, and the proportion between them varies enormously from one woman to another. In some, the milk-making machinery accounts for a small fraction of the breast. In others, it fills a great deal of it. From the outside, you cannot tell which is which means the visible size of a human breast is a poor guide to what it does. Women with small breasts feed infants successfully. Women with large breasts sometimes struggle. Milk supply is governed mostly by demand, by how often and how effectively an infant feeds, which signals the body to make more. The fat is not a reservoir of milk. It is something else. So we are left with a genuine evolutionary mystery, and it is a mystery about the most familiar object in human life. Every one of us was fed by one. Billions of words have been written about them in art, advertising, medicine, and law. And biology still cannot say with confidence why they exist in the form they do. The first thing to understand is how unusual the human pattern is, even within our own family. In chimpanzees, gorillas, orangutans, and bonobos, the mammary tissue swells when it is needed, and recedes when it is not. A lactating chimpanzee does have small visible breasts. When she weans her infant, they flatten again. The signal, if it is a signal at all, says one thing: I am currently feeding a baby. The human pattern says something different. Human breasts appear at puberty and remain. They change with pregnancy, with weight, with age, with each child, but they do not vanish between children. They are permanent structures on the body of a female primate, who may not be pregnant, may not be nursing, and may not intend to be either. In evolutionary terms, permanence is expensive and permanence is loud. Tissue costs energy to build and carry. It has to be supplied with blood, and a structure that stays visible, whether or not it is functionally in use, is exactly the kind of thing that makes biologists suspicious. It looks less like a tool and more like a statement. That was precisely the conclusion of a zoologist named Desmond Morris, whose book The Naked Ape landed in 1967 like a stone through a window. Morris argued that human breasts were a sexual signal, and he proposed a mechanism so vivid that it has never quite left popular culture. Our ancestors, he suggested, had once signaled with the rear of the body, as many primates do. Then we stood up. We began to interact face-to-face, to court face-to-face, to mate face-to-face. And in that reorientation, a new signal evolved on the front of the body, a pair of rounded, fleshy hemispheres that echoed the old ones. It was elegant, it was memorable. It was also, on close inspection, almost impossible to test, and it carried a hidden assumption that would take decades to fully examine. The assumption was that everyone finds breasts erotic. Morris was a mid-century Englishman writing for a mid-century Western audience, in a culture saturated with a particular kind of imagery, and he treated that response as a fact of human nature rather than a fact about his own world. When anthropologists went back through the ethnographic record, hundreds of societies documented across every inhabited continent, that assumption came apart. In a great many of those societies, breasts were not described as a primary focus of erotic interest at all. They were functional, unremarkable, often uncovered, and about as sexually charged as a forearm. The intensity of attention varied dramatically from place to place. That does not destroy the idea that breasts are a signal, but it complicates it enormously, because it shows how easily a local cultural obsession can be mistaken for an ancient biological law. And it raises a harder question that sits underneath the whole subject. When we try to explain the human body, how do we know we are not simply explaining our own habits of looking? The problem deepens when researchers actually measure preference. In one line of experiments, men were asked to rate female figures, and the results shifted depending on the state of the man doing the rating. Men who had not eaten for several hours tended to prefer larger body sizes and larger breasts than men who had just eaten. Preference, in other words, was not a fixed dial installed by evolution. It moved with hunger. It moved with circumstance. Comparable patterns turned up across cultures and economic conditions. A drift toward preferring signs of stored energy in environments where energy was scarce. That is a clue, and it points somewhere unexpected. Perhaps the interesting thing about breasts is not that they are attractive, but what they might be attractive about. Which brings us to a hypothesis proposed by an American anthropologist named Frank Marlowe, who spent years living among the Hadza of northern Tanzania and thinking about how humans choose long-term partners. Marlowe noticed something that the buttock mimicry idea entirely ignored. Breasts change over a lifetime, and they change in a way that is difficult to disguise. They rise, and then, with time, with childbearing, with the gradual loss of skin elasticity, they descend. The change is gradual, and it is largely involuntary. To an evolutionary biologist, that combination is fascinating because it describes what is known as an honest signal, information that is hard to fake and therefore worth attending to. Marlowe's argument was that human breasts function as a readable indicator of age, and specifically of remaining reproductive years. In most primates, this would be a peculiar thing to advertise, because in most primates, males do not commit to a single female for a decade. But humans do something unusual. We form long-term pair bonds. We invest, both parents, over years. And the moment a species starts making long commitments, accurate information about age becomes extremely valuable, because a decade-long partnership formed at one point in a life is a very different proposition than the same partnership formed later. There is one prediction from this idea that turns out to be quietly striking. If breasts were primarily a device for feeding infants, you would expect them to develop when they were needed, at or near the onset of fertility. They do not. In human girls, breast development typically begins around a year or two before the first menstrual period, and the first menstrual periods are often not fully fertile. There is a window, usually of a year or more, in which the reproductive system is still coming online. So the structure appears, conspicuously, before the biological function it supposedly serves, and it announces a transition that has not yet finished happening. Every mammal grows mammary tissue. Only humans grow it early, keep it permanently, and pack it with fat. And that word, fat, is where the story turns, because it opens onto something far bigger than attraction. Here is a fact that surprises almost everyone who hears it. Humans are the fattest primates alive, not through modern diets, though those amplify it, but by baseline biology. A healthy adult woman carries substantially more body fat, as a proportion of her weight, than a wild chimpanzee or gorilla could ever carry. And the pattern begins before birth. A human newborn arrives with roughly 15% of its body weight as fat, making it one of the fattest newborns in the entire mammal class. Not fat like a mouse pup or a puppy, fat like a young seal. Then it gets fatter. Over the first year of life, human infant body fat climbs, peaking somewhere around 9 months to a year, at a proportion higher than most adults carry. Picture the classic image of a healthy baby. Creased wrists, dimpled thighs, cheeks like plums. That is not incidental cuteness. That is a metabolic strategy, and it is nearly unique to our species. Why would evolution build a fat baby? The answer sits inside its skull. The human brain is the most expensive organ any primate has ever grown. In an adult, it accounts for roughly 2% of body weight and consumes something close to 20% of resting energy. In early childhood, when the brain is building itself at furious speed, the proportion of the body's resting energy budget devoted to that one organ climbs toward half. There is no other animal that spends like this, and a brain has a terrifying vulnerability. It cannot go hungry. Muscle can wait. Growth can pause. Neural development cannot simply be postponed without consequence. So the human infant carries its own emergency supply. The fat is a buffer, a private energy reserve that stands between a growing brain and the ordinary interruptions of life in a world without refrigeration or reliable harvests. Illness, a bad week, a mother's temporary shortfall. The baby is, in a very real sense, insured, and the mother is insured too. Breastfeeding a human infant costs a substantial amount of additional energy every day, on the order of several hundred calories, sustained for months or years. Human milk itself is not especially rich. It is dilute, low in fat compared with the milk of seals or rabbits, which means human infants must feed often and continuously rather than in occasional enormous meals. The whole arrangement assumes near, constant contact and a long, unbroken supply line. Any woman doing that in an ancestral environment, foraging, walking, carrying, sometimes going without, needed reserves of her own. This is where the fat hypothesis for breasts entered the conversation. Perhaps the breast is simply part of a larger human adaptation, a species that stores unusual quantities of energy under the skin, in a body that lost most of its fur, to feed the most demanding brain in the animal kingdom. But there is a complication, and it is the kind of complication that makes a mystery better rather than worse. If breast fat existed as an energy store for lactation, you would expect it to be spent during lactation. What researchers actually find is that the fat which appears to matter most for reproduction is somewhere else entirely, on the hips, the thighs, the buttocks. That gluteal fat behaves differently from fat elsewhere on the body. It is laid down at puberty under hormonal control. It is stubbornly resistant to ordinary dieting, and it is preferentially drawn upon during pregnancy and breastfeeding. Some researchers have argued that it is also unusually rich in the long-chain fatty acids that a developing brain needs most, the specific molecular building blocks of neural tissue. In other words, the pantry appears to be on the lower body. The breast, sitting on top of the milk, making glands, is not obviously the strategic reserve at all, Paul Henry, which leads to a strange and rather beautiful possibility. Perhaps the human breast is not the storehouse. Perhaps it is the sign on the storehouse door. Consider how honest signaling works elsewhere in nature. A peacock's tail does not help it fly. A stag's antlers do not help it eat. What they do is demonstrate unfakeably something about the animal carrying them, that it can afford the cost. Fat is expensive to acquire and expensive to carry. In an ancestral environment, visible stored energy on a human female body was not a fashion statement. It was evidence that she had access to food, that she had been well fed through development, that her body was in a condition to support the enormous metabolic project of growing a human brain. And unlike a cyclical swelling that comes and goes, a permanent structure carries that information all the time, to everyone, continuously. That fits an odd, broader pattern in our species. Humans lost the conspicuous cyclical signals that many primates use. There is no obvious external announcement of ovulation in a human female. Our signals are continuous rather than episodic, always on, never precisely informative about any single moment. The permanent breast sits comfortably inside that pattern, whatever else it may be doing. If following an ordinary question about the human body into this much unresolved biology is the kind of thing you enjoy, a like or a subscription genuinely helps these longer investigations reach people who like sitting with unfinished answers. Now, back to the problem, because there is a serious objection waiting, and it comes from people who think the entire question may be framed wrongly. The objection is this: not everything on a body is there for a reason. In 1979, the biologist Stephen Jay Gould, together with the geneticist Richard Lewontin, published an argument that would irritate and reshape evolutionary biology for decades. They pointed to the architecture of a great cathedral, to the curved triangular spaces that appear where a dome meets the arches beneath it. Those spaces are often filled with gorgeous painted figures, fitted so perfectly that a visitor assumes they were designed for the art. They were not. They are the unavoidable geometric leftovers of putting a dome on arches. The art came afterwards, into a space that already existed. Their warning was that biologists were doing the same thing in reverse, seeing a structure, assuming a purpose, and then constructing a story to fit. Some features are simply consequences of building a body a particular way. And there is an uncomfortably good candidate for that kind of explanation here. Human beings, alone among primates, lost most of our fur, and we accumulate fat directly beneath the skin across the whole body in a way our relatives do not. Human fat deposition at puberty is orchestrated by hormones, and the breast is densely populated with receptors for those hormones. Deposit subcutaneous fat generously across a hairless primate body. Run that process through a strongly estrogen-driven puberty, and place it over glandular tissue that is already there in every mammal, and a projecting breast may simply be what you get. Not a signal, not a strategy. A consequence. There is a small, quiet piece of evidence that supports taking the byproduct idea seriously. Human males have nipples. They have rudimentary mammary tissue too. This is not because it does anything for them. It is because in early development, before the pathways of sexual differentiation diverge, the embryo lays down the same structures in everyone. The male nipple is a reminder that bodies are not assembled from optimized parts chosen individually. They are grown from shared instructions with side effects. So the honest position is that we have at least 3 serious families of explanation: signal, store, and byproduct, and they are not mutually exclusive. A structure that began as a developmental side effect can later be recruited by sexual selection. A signal can become more elaborate once it exists. Evolution does not care which came first, and it leaves no note. But there is one perspective we have almost entirely left out, and it belongs to the only creature with a genuine, urgent, non-negotiable interest in the human breast. The newborn arrives nearly blind. Its visual world is a blur of light and shadow, with almost no detail beyond a short distance. It cannot hold up its own head. It cannot crawl in any coordinated way. And yet, placed on its mother's body, an undisturbed newborn will often begin a slow, lurching migration, pushing with its legs, bobbing its head, mouth working, and find the nipple on its own. Researchers who have filmed this have watched it happen again and again, without guidance, within the first hour of life. How does a creature that cannot see find its target? Largely by smell. The area around the human nipple is studded with small glands that secrete an oily substance, and newborns respond powerfully to that odor. In classic experiments, infants presented with a choice between a washed breast and an unwashed one turned reliably toward the unwashed side. The signal that matters to the infant is not visual at all. It is chemical, and we have scrubbed at it for a century without realizing it was information. There is also a visual change that has never been fully explained. During pregnancy, the areola typically darkens. It is one of the earliest and most consistent pigment changes in the human body, and while it is driven by hormones, the question of whether it serves any function remains open. One suggestion is that increased contrast helps an infant with poor vision locate a target. It is difficult to test, and it may be nothing. But it is a reminder that the structure we are trying to explain sits at the meeting point of two bodies with two different sets of needs, and evolution had to satisfy both. That two-body relationship produced another hypothesis that sounds convincing until you examine it. Human faces are unusual among primates, flat, with a small jaw and a projecting nose, quite unlike the muzzle of a chimpanzee. Some have proposed that a projecting breast evolved to give a flat-faced infant something it could latch onto and seal against. It is a satisfying image. It is also weak in the details. Infants latch onto the nipple and the surrounding areola, not the fatty mass. The shape of the fat is not what makes a seal possible, and infants of every breast size manage the task. The hypothesis has the shape of an answer without the substance of one. Still, it points at a real feature of the human situation, and one that has nothing to do with signaling. Human infants are unusually helpless for unusually long. Human mothers, in traditional settings, nurse for years while also foraging, walking long distances, and often carrying the child. Everything about the arrangement is stretched. The dependency, the energy demand, the duration. Whatever the breast is, it exists inside the most metabolically extreme parenting arrangement in the primate world. At this point, you might reasonably ask why we cannot simply look at the fossil record and see when breasts appeared. The answer is brutally simple. Fat does not fossilize. Skin does not fossilize. There is no bone that records the presence or absence of a permanent breast on a female Homo erectus. On the single question we would most like to answer, when did this begin? The physical record is silent. Almost silent. In a cave in southwestern Germany, an archaeologist named Nicholas Kennard was working through the sediments of a site called Hohlefels when his team recovered fragments of carved mammoth ivory. Reassembled, they formed a small figurine, a female human body, no larger than a thumb, with the head replaced by a carved ring, as though it had been made to hang from a cord. It is somewhere between 35 and 40,000 years old, among the oldest unambiguous depictions of the human form ever found. And it is carved with enormously exaggerated breasts. Imagine holding that object. The oldest surviving portrait of a human being made by human hands, small enough to close your fist around, worn smooth by fingers that have been dust for 400 centuries. Whoever carved it made a choice about what mattered most about a human body, and they made the same choice that would be made again and again across Ice Age Europe, in the limestone figure from Willendorf, in figurines from France to Siberia, all emphasizing breasts, hips, and abdomen. It is tempting to read that as proof of ancient obsession. Be careful. We have no idea what those objects meant. They may be depictions of fertility, or of specific individuals, or of pregnancy, or self, portraits viewed from above, or ritual objects whose logic is entirely lost. What they do establish is narrower but not trivial. For at least 40,000 years, human beings have looked at the human body and found the breast worth representing, in stone and ivory, over and over, across thousands of kilometers and hundreds of generations. Whatever biology built, culture has been thinking about it for a very long time. And culture has thought about it in wildly incompatible ways, which is itself part of the puzzle. The same structure has been treated as sacred and as scandalous, as maternal and as erotic, as something to expose and something to conceal, sometimes within the same city in the same century. Very few features of the human body carry that much semantic instability. Our elbows do not require legislation. Something about this particular tissue sits at an unusual intersection of feeding and desire, of the private and the visible, and human societies have never stopped renegotiating what it means. There is one more part of the ledger that must be mentioned, because evolution does not deal in unmixed gains. Any explanation of why humans carry permanent breast tissue also has to account for its costs. Carrying additional weight on the upper body has real mechanical consequences for a bipedal skeleton, and it can make sustained physical activity more difficult. More significantly, the human breast contains a large amount of hormonally responsive glandular tissue, maintained across an unusually long lifespan, and tissue that is repeatedly stimulated to grow and remodel over decades carries risk. Diseases of the breast are among the most significant health challenges women face worldwide. Other mammals develop mammary disease too. We are not uniquely afflicted. But the human combination of permanent hormone, responsive tissue, a long life, and relatively few pregnancies compared with our ancestors appears to be a demanding one. That matters for the argument because it raises the stakes. If this structure carried no cost, we could shrug and call it a harmless quirk of development. Costs imply pressure. Something maintained this feature despite its price, or the developmental architecture that produces it is so deeply entangled with the rest of human biology that it cannot be edited out. We do not know which, and that uncertainty is not a failure of effort. It is a feature of the question. Here is what makes questions like this one so hard. To explain why human breasts are large, you would need to compare us with a close relative that lacks the trait and identify what differs. But our nearest relatives that might have offered that comparison, the other species of humans, the Neanderthals, the Denisovans, the small-bodied people of Flores, are gone. We are the sole surviving member of a once crowded genus. Every comparison we make is with a lineage that split from ours millions of years ago, across which almost everything about reproduction, brain growth, diet, and social structure changed at once. When too many variables move together, causation becomes nearly impossible to isolate. And there is a second, subtler difficulty. When scientists study why a moth's wings are patterned a certain way, they bring no personal investment. When they study the human body, they bring an entire culture with them. Assumptions about who looks at whom, about what is attractive, about what women's bodies are for. The history of research into human breasts is partly a history of researchers discovering their own era's preferences and mistaking them for the deep past. That is not a reason to abandon the question. It is a reason to hold the answers loosely. So where does that leave us? With something more interesting than a solution. The human breast appears to be the intersection of at least 4 extraordinary things about our species, any one of which would be remarkable on its own. We are the primate that lost its fur. We are the primate that stores fat like a marine mammal. We are the primate that grows a brain so expensive that infants must arrive loaded with their own fuel. And we are the primate that forms long partnerships, which means we spend our lives reading each other for information about age, health, and condition, continuously, unconsciously, and often wrongly. The permanent breast may be a signal, or a byproduct, or a reserve, or all three at different points in a long history, each function layered onto a structure that arose for a different reason. Evolution is not a designer. It is a tinkerer working with whatever is already there, and it keeps no record of its intentions. What is certain is this: for millions of years, mammals have carried mammary glands that appear when needed and recede when they are not. Somewhere along the line that led to us, in a lineage learning to walk upright, to shed its fur, to store energy under its skin, and to grow brains that could eventually ask questions about themselves, that ancient arrangement changed. The tissue stayed. It filled with fat. It became visible, permanent, and, for reasons we still cannot fully account for, one of the most culturally loaded structures in the natural world. A chimpanzee mother looks at another chimpanzee's chest and sees nothing worth noticing. We look, and we see age, health, motherhood, desire, identity, sometimes shame, sometimes the sacred. The tissue is much the same. The difference is entirely in the animal doing the looking. Which raises the question that all of this has really been circling. How many other parts of ourselves do we assume we understand, simply because we have been looking at them our entire lives?